Hello and welcome to another video of myself analyzing the websites of quantum computing, quantum communication and quantum sensing, so quantum technology companies. In today's video we are going to look at a very special one because we are looking at Quantum Computing Inc. And actually that's even their domain, it's quantumcomputinginc.com. So it's probably the quantum computing company, right? Let's find it out together. So looking at the website, what we already see is this very futuristic box here, which says Dirac 3 on it. Probably Dirac, because it's a physics or a physicist. We see something that looks like, I don't know, wafers maybe next to it. And it says, putting photons to work, get started for free. So probably there is some online service that we can use right away. But before we want to do that, let's see what else they say here. So they say foundry services. The QCI foundry is fabricating photonic computing engines using thin film lithium niobate TFLN, enabling the future of integrated photonics. And then we see quantum mechanics here. We provide accessible and affordable photonic technology to drive the future in high-performance computing, communications, and more. So, obviously, we are in a photonic space. So this is light, very fancy word for light. So we are looking at quantum devices that work probably with single photons or with light or electromagnetic waves. We see some foundry services, so that's probably in the processing, in the creation of those devices. Looks like we have like electro-optical devices here, so maybe wafers with some optical elements on them, like waveguides. That looks at least like it could be a waveguide here. And then it says quantum mechanics here on the other side, and the application areas, which are high performance computing, communications, and more. Okay. Then we have a press release here. There's the video over here. Here it says who we are. In this brief video, discover how QCI is transforming the future with cutting-edge quantum and photonic technologies. From our groundbreaking hardware to innovative scientific advancements, we are pushing the boundaries of what's possible. Learn how our solutions are driving progress in computing, AI, communications, and more. Stay tuned to find out how we're making quantum technology a reality today. Okay, that's a big claim. They're making quantum computing technology a reality today. So here's whom they work with. We see different universities and governmental agencies, like for example NASA here, Los Alamos National Laboratory. So these are all very big labels up here. Then there's some more about QCI, Quantum Computing Inc. Apparently, it's also a stock listed company. So it says here NASDAQ QUBT is an innovative integrated photonics company that provides accessible and affordable quantum machines to the world today. QCI products are designed to operate room temperature and low power at an affordable cost. The company's portfolio of core technology and products offer unique capabilities in the areas of high-performance computing, artificial intelligence, cybersecurity, as well as remote sensing applications. So, as we see, they are not only creating quantum computers, but they also do other stuff with the photonics technology that is at the core also of their quantum technology. Then there's something about publications here. So also this company is publishing their research results openly or at least partially. And then there's some button here to probably see the careers page. Okay, then down here we can also join a marketing email list. That's also good to know. Now let's take a look at the upper part of this website here. So we first go to the Foundry tab. We see some wafers here, very nice and shiny wafers. Thin film lithium niobate foundry. Lithium, I don't know. you can tell me how to pronounce it down in the comments below. So QCI built a first of its kind foundry devoted to processing thin film TFLN and other transition metal ferroelectrics in Tempe, Arizona. So interesting, they built their own foundry. We closely work with our clients on conventional TFLN projects and also undertake highly custom engagements that leverage our extensive design, fabrication, and characterization expertise. So they also work like a fab. If you know the semiconductor industry a little bit, there are a lot of companies that are creating chips, but they are fabless. So what does it mean? They basically design something, but they don't manufacture it themselves. There are a couple of big fab providers. They are basically like platform marketplace providers. They have all the technology that you need to build these very tiny transistors that you have in your computer, smartphones, whatever. And these companies, like TSMC is one of the, I think it's the biggest one is TSMC, but there are also others. They basically let you submit your design and then you can get it manufactured from them. And that's what a fab is basically doing. And here we see that they have this very specialized technology, and they not only use it to build their quantum computers, but they also offer these very special fabrication techniques to others as a fab, because they can manufacture that. So the IP does not only lie within quantum computing, but also within this technology and the foundry services that they are providing. Here's what they make. So they make passive devices, micro rings, linear devices, EMOS, and nonlinear devices, PPLN. Let's see what the text here says. The foundry offers both front and back end capabilities for photonic integrated circuits, PICs, including packaging for a 150 millimeter wafer line. We further support many of our customers throughout the entirety of their project, offering design, simulation, and characterization services for TFLN devices. The most common devices fabricated at QCI are EMOS. So these are these linear devices that we see here, where we have probably here these linear waveguides. Where were we? EMOS, phase modulators, ring resonators, and filters, nonlinear PPLN waveguides, and microrings, and many more. Enabling integrated photonics. So here we see one of these waveguides. We see the roughness, which is apparently very smooth. So this is nanometer here on the scale, and we see that's really like in the nanometer smoothness. So they're very, very precisely manufactured waveguides on these probably silicon wafers. We see that it's crystalline material with large optical nonlinearities. This is probably referring to the dispersion relation, right? I'm not an optics expert. You can see it right away. TFLN is at the forefront of miniaturizing optical systems and significantly extending the capabilities of bulk lithium niobate, which has been an industry standard for over 60 years as the active element in transducers. Okay, yeah, then we see here the smoothness, and then here we see some simulation of a micro-ring resonator. Okay. The future of integrated photonics, high density encoding, power efficiency, heterogeneous integration. That's all very important when it comes to like the fab related things, I guess. Power efficiency relates to the performance of the end device. So heterogeneous integration is probably about how the design freedom is possible on the chips. So here we also see something about flip chip bonding, so how to bring this chip on another chip, on how to connect it. So this is a specific technique. We also see CMOS, which is very important because when it comes to standard fabrication technologies like silicon wafers, like the chips that, I don't know, Intel is making, or that you have in your iPhone, whatever, like the standard silicon technologies usually CMOS, and it includes only a very specific type of materials, and certain materials they are not allowed in this CMOS fabrication because they contaminate your whole system and so on. That's worth a whole nother video, I would say. Let's take a look at the products as well. That looks very shiny here. So we see those boxes that we saw before. There's the Dirac 3, which is an entropy quantum computer. Okay, so then we have the MU Core, which is a first generation reservoir computing product. Okay, entanglement source. Not sure which is which though, but maybe, okay. That's what an entanglement source looks like. It's a QCI's product for creating broadband entangled photons across the entire telecom C-band. Then we have a frequency converter. Quantum frequency conversion is essential for a wide range of applications, especially in quantum optical information processing and sensing. And then we have the UQRNG, which is a uniform quantum random number generator product. All of these have different roles. So some of them are, let's say, well, they're all in a way in the quantum technology. So you see there's quantum computing, for example, here, the entropy quantum computer. But you also have this random number generator, which probably plays a role when you want to build something with, let's say, encryption to it, and you need random seed phrases or something like that. Maybe this could be interesting. Then you have this entanglement source, which is probably interesting for quantum communication as well. And then, frequency converter as well, but also for information processing and sensing, it says here. So this could be also interesting for sensing. This is like the commercial products, and there are also R&D offerings. Those will go probably into labs. So here we have remote sensing, quantum cybersecurity, imaging, and a vibrometer. Vibrometer is a cost-effective solution for various remote sensing applications. Imaging is photon-sensitive optical imaging systems. Okay, cybersecurity is what we talked about before, so quantum cryptographic protocols. Remote sensing is about sensing, right? Then let's also take a look at the technology side of things. One technology, many applications. That's always what we like to hear, right? If you develop a core technology and you can put a lot of different applications on top for a company, this is important to get some also stable revenue, right? Because you can basically hedge across different areas, across different applications. So here it says using quantum optics and nanophotonics to solve real-world problems is a new and emerging field with new applications constantly being discovered. We are exploring high-performance computing, cybersecurity, imaging, and sensing, all from this same starting point. Okay. Quantum machines for a brighter future. The QCI core technology is based upon leveraging light and its quantum mechanical properties as a versatile tool that, when manipulated incorrectly, can be used as a component for many different applications. Okay, and then we have the value in quantum today, which is high bandwidth, fast processing, low energy consumption. So this new technology apparently also allows to generate light in a more efficient way. Otherwise, it wouldn't be lower power consumption, and measure maybe also lower intensities of light. Okay, then we see here the new foundation, and we have some products down here again. So the quantum computer, the reservoir computing, sensing and imaging, quantum cybersecurity. That's what we saw before, and there's, I think, a bit more information here what those different products actually do and in which context they might be able to be used. So here we also see something about quantum number generator. UQRNG is a portable device that provides genuine random numbers directly from quantum processes. I don't know what is wrong with reading today. It can be used as a standalone device or integrated into other hardware modules as a quantum entropy source, enabling solutions for seeding and creation of random keys for cryptographic protocols, trustworthy choices in gaming and lottery, fair selection, and a distribution in blockchain or in unbiased randomness in simulation. So it basically uses the properties of quantum mechanics to generate a truly random number by basically, let's say you could, for example, take a quantum system, put it in a superposition where both states are at the same probability, or yeah, basically you can say you put it in a position where both states are at the same probability, and then you let it collapse, which means you measure it, and then it will collapse in one of those two states, 1 or 0, and thereby you create a random number. And of course, if you have a machine that can do this pretty quickly, you can generate large random numbers that are truly random because of the underlying core principle of quantum mechanics. We have something about authentication here. So QCI's quantum authentication eliminates vulnerabilities inherent in classical cryptographic schemes by offering a comprehensive entanglement-based quantum cyber solution that seamlessly integrates into existing telecom fiber and communication infrastructure. This groundbreaking design incorporates interchangeable local measurement devices, enabling the concurrent operation of multiple cryptographic protocols. QCI's solution is engineered to be compact, cost-effective, and operational at room temperature, offering a versatile and accessible solution for secure quantum communication and authentication. So this is probably very much the machine that you need to build a quantum communication network. It doesn't say much here about, let's say, the distance that it can work on, but what is very interesting is it works at room temperature, so you don't need to put a big cryostat like the ones that we saw in the quantum computers before, but really probably only this small box. And the other important thing is it works on normal communication fibers. So the ones that are already there. So you could, in principle, just take one of these optical fibers that you already have and connect two data centers with this. And then you can make sure that these can communicate with each other in an encrypted way that cannot be broken by the principles of quantum mechanics. So this is this quantum communication. We will definitely also do a video about this to explain exactly how it works. Well, I wouldn't say definitely. Let me know in the comments down below if this is interesting to you or not. And then we do it. If you want to know how it works, we do it. Otherwise, you can look it up somewhere else. Okay, or you might already know it, right? Let's take a look at the company side here. There we see again this video, which I'm not going through now. Our in-house expertise. So here we see what all has to come together to form this company. So we see quantum physics, quantum optics, which is the light part of things, right? We have the quantum physics part is, for example, relevant for the communication schemes, right? To basically make sure that we understand the quantum physics. Quantum optics relates to those light sources, detectors, and so on, like polarizers and whatever you need to build this. I'm, as I said, not the absolute expert on it. Then we have hardware and electrical engineering, of course, because you need to build, amplifiers to actually amplify those signals. Because you're working with quantum systems, they only create very, very small signals. And if you just boost them up with your normal amplifier that you have in your, stereo system, then you get a lot of noise. So you need to have somebody who understands very well and use a very sophisticated way of amplifying those. You need nanofabrication. That's what we saw before. These like super tiny structures on the wafer that have like super smooth surfaces in the nanometer range. They need to be engineered. For that, you need somebody who knows nanofabrication. Then we have FPGAs and embedded design that also relates to the signal processing. You need very special signal processing units and these FPGAs, so field programmable gate arrays, and embedded design is like very specialized hardware that is made for this specific application. Then you have mechanical engineering and product design. That's of course clear. You always need this. And if you want to build a physical product, you need somebody who understands mechanical engineering and product design. Then you have the algorithm development, because if you want to build, for example, this quantum communication algorithm that we talked about, this quantum communication system, you also need some algorithm, right? You need to be able to get all of these signals together, process them in a way, and that's what an algorithm does. And then, of course, there's firmware and software development. well, that's also kind of clear. Then we have here something on the intellectual properties. This is also a very important point. We have all of these very exciting quantum technology companies out there right now, right? And we need to make sure, or the companies need to make sure, that if they build those USPs, they also take into account the intellectual property side of things. Because creating all of this is one thing, but if somebody else is copying it and just taking it and monetizing it, you will not gain anything from it. And as a company, you also need to make profit, right? So you have to save this intellectual property in some way. And that doesn't necessarily mean that you don't give others, let's say, entry point to this. But it could also be that there is, let's say, a huge corporate coming, taking your technology, using it, and then creating a couple of patents around it so that you yourself can't do your business anymore. So that's why it is also important to take this into account, right? Okay, and then we have here something about the foundry again, the leadership team. I won't go through all of this. Then we have investor relations. As this is a stock listed company, I guess they also have to do some reporting here, do financial reporting. And you also see the stock prices here, I guess, just because of regulation, right? Then there's a source library here. I guess that includes also the publications, right? We see some introductory material to the different products here. Let's go maybe on this quantum computer. Okay, so we see some basic introduction, how it works, some spec sheets. Okay, gentle introduction to optimization, very interesting. I think to also explain how this machine works, because it's not like right in front of on the website, and I'm also not an expert, so I would have to let's say go into the details myself as well. But if you want to see me do that, or if you want to have a video where I prepare this, also, as always, just let me know down below, and then we will do a specific video on this as well. And I think with that we can already call it, because we have been going through all of the different parts of the website. With that, as per usual, make sure to always stay hydrated, and see you in the next one. Bye bye.